is completing the square. Okay. Now, many of you, when you're given problems where there are no factors of -3 whose sum is that middle term -6, so this is not going to have rational zeros. Okay? There's not going to be binomial factors for this. So your solution is going to be an irrational number, going to have square roots in it. And so in order to solve those, you need to either complete the square or use quadratic formula. Okay? So many of you rely on quadratic formula, but if you get a calculator to use and do the calculations with quadratic formula, you might as well use the solve feature, right? Okay? But completing the square allows you to do all of these and work with smaller numbers than the quadratic formula does. So I would recommend using completing the square as often as possible if you have to do these by hand, and it's not rational zeros where you can factor it. Okay? And the way that you complete the square is the following. Have we gone through completing the square in anything? No? Okay. So your first step is you're going to isolate your constant, right? Meaning you're just going to move your constant over to the other side. Notice I left a space here to complete the square. Once you isolate your constant, what you're then going to do is you're going to do the process of completing the square. Okay? And that process involves first, take 1/2 of your first degree term's coefficient. Okay? I'm going to call that b. b is the coefficient of x, right? The first degree term's coefficient. You're going to take 1/2 of that b value, you're going to square it, and you're going to add it to both sides. Okay, so if we take 1/2 of our b value is -6, so -6 divided by 2 is -3, okay, and we're going to add that to both sides. So we're going to take 1/2 of -6 squared and add it to both sides. Now, notice in this case I wrote it out, but normally you'll just do it as a mental calculation. So really that step would look like this. You'd take -3 squared is +9 is equal to 3 plus 9. So you would add 9 to both sides of the equation. Once you get that, the whole point of doing these steps right here is it puts your left side of the equation, or in this case the side with the x's, into the form of a perfect square trinomial. Okay, meaning this is the pattern of a binomial square expanded. Okay, and the terms are x, and then whatever this 1/2 value was, we saw that it was -3, that's going to be our second term of the binomial. And then we just combine what we have on the other side. So that step is rewriting as a binomial square. Okay, and then the final step is going to be to solve the resulting equation. So now if we solve for x, we have this binomial square. We can extract the square root. X minus 3 is equal to, take into consideration the positive and negative root. Square root of 4, or square root of 12 is 4 times 3. Square root of 4 comes out as a 2. 3 stays under the radical. Add 3 to both sides, and we get our solutions. X is equal to 3 plus or minus 2 root 3. So those would be our two solutions for this problem. Now, those exact same steps can be followed even if your leading coefficient is not a 1. And the way to do that, or what would be required here, is after you isolate the constant, what you would do is divide to get leading coefficient to be 1. Okay, so that is part of that first step. So the process on this second problem would be, as I move my term over, I'm going to divide everything by whatever my leading coefficient is, so that my leading coefficient is now a 1. So I get x squared plus 2x, and I'm going to move my constant over becomes 3/4. Okay, it's fine that it has fractions. You can still work with fractions here, because when I complete the square, I'm going to take half of my first degree term's coefficient, and I'm going to add that squared value to both sides. So half of 2 is 1, 1 squared is 1. So I'm adding 1 to both sides. Now, because I'm working with a fraction form here, when I add 1 to the right side to balance my equation, 1 is how many fourths? If you think of it in terms of the fraction form, it'll make it easier. So that gives you here a total of 7/4. And now you can rewrite your binomial square. Our left side is the binomial, is the expanded form of x plus 1 squared. Our right side is 7/4. And then the final step of solving involves extracting the square root. So you get x plus 1 is equal to, take into consideration the positive and negative root. 7 stays inside the radical, but square root of 4 simplifies to 2. Subtract 1 from both sides. Now, because I'm working with a fraction with the denominator 2, when I move it over, I'm not going to subtract 1. I'm going to subtract how many halves? 2 halves. And so that gives me, x is equal to negative 2 halves plus or minus 7 halves. And so when you write your answer, you get negative 2 plus or minus 7 all over 2. Now, if you enter your answer as negative 1, or if you enter the what? Oh, square root, thank you. If you enter your answer as negative 1 plus or minus the square root of 7 over 2, that's fine too, but often you're going to see the numerator written in that combined sort of rational form.